Good morning, guys. I hope you're doing well today. Sorry, my voice is a little scratchy. I apologize for that. Couple of things that I wanted to remind everybody of. There is a scavenger hunt that is in quizzes, and you'll see the scavenger hunt exercise. Again, this is to show you where important documents for the course are. Almost all of those documents are in the content. I did have one question that came up about this, and that was where the exam handouts are. They are here. So they are right here as well. And you can see exactly what you would get. On a physical test, you would be handed these. For you guys, I'm expecting that you're going to print them out and have them with you during the test. You'll get to show them to the respondus monitor and say, hey, look, I have these. And the only reason I need to see them is to make sure you haven't written anything else on them. Okay, so there's that. I do have a couple of people who haven't signed up for Alex yet. And of course, the link to get to Alex is here under course documents. So if you click the Alex and then the MH Campus Connect, that will take you into Alex. And this, you can click Alex here to get signed up for Alex. Please make sure that you do that because all of your virtual labs and your homeworks are located within Alex. So there is that. The other thing, just in case you had forgotten, there is a quiz that goes with every lecture. Now, typically what's going to happen with these quizzes is that they'll be open at midnight the day of the lecture. They cover, the topics for the day. So what are we going to talk about that day? And then what are things that we covered last time that I think that you should be able to do? Now, please don't freak out about these because even though they get graded, quote unquote, and you get a score that may not be 100, at the end, after I've had a chance to review that, everybody will get a pass-fail on it. So you either took it or you didn't. Normally, those will close 10 minutes after class start or 5 minutes after class starts. Today's is open until just after noon, just to make sure that you guys have had a chance to do it. The questions that come from the previous lecture will come from the review that we do during class. So I don't want you working on that while we're talking about it, and that's why it closes when it closes, okay? So those are the reminders that I have. Do I have any questions, comments, problems, concerns from anybody before we get started? Okay, I don't hear anything. So I'm going to go ahead and close this down, open this back up. And let's get started. So one of the things that I mentioned is that we will go through our topics. These are in the beginning of each of the lectures that you guys have. Today we'll be talking about the atomic theory of matter, an atomic mass unit, which is an AMU, mass number, atomic symbol, isotopes, atomic mass, and the difference between atoms, ions, and molecules. So those are our topics for today. In addition to that, this is practice. Now, the majority of the questions that you'll get on the quizzes come directly from this practice. So if you want to do them before you do the quiz, that's fine. But this is what we're going to be talking about. So I said, calculate the mass in grams of 2 cubic inches of gold. The density of gold is 19.3 grams per centimeter cubed, and 1 inch is 2.54 centimeters. So I need to get from this grams per centimeters cubed, the units that I have now, I want mass, sorry. And that's going to be in grams. I have a density that's in grams per centimeter cubed, and I also have a dimension for this of 2 cubic inches. Okay, so 2 inch cubed is what I start with. That's what I know about this particular piece of material. So I know it's 2 inches cubed. I know that 1 inch is equal to 2.54 centimeters. And that's helpful, but it's not enough because that needs to be cubed in order for me to use it. So I'm going to have to cube both the top and the bottom to get those units canceled. Now that inch cubed is still 1, so that'll cancel with the inch cubed. That 2.54, I'm actually going to have to cube when I do this. So 2.54 times 2.54 times 2.54, which gives me this value, 16.38764 centimeters cubed. And I'll multiply that by the 2 inches that I have. And that will give me that dimension is 32.774128 centimeters cubed. Awesome. That's part of it. Now, since I have a density that's in grams per centimeter cubed and I want a mass in grams, what I can do is take that density, that 19.3 grams per centimeters cubed, because that's the number that they gave me right here. And then I can multiply that by this dimension that I just calculated, the 32.774128 centimeters cubed. And that will give me the number that I'm looking for. 632.5406704. And of course, that unit is now grams. Now, do I want to report all of that? Well, no, technically I don't. Since I got my starting number was only one significant digit, I would report this as 6 times 10 to the third grams. Okay, because that's one significant digit. I'm not that concerned about that right now. I just wanted to make sure that I mentioned it. Now, when I do this, I would do this as a series of calculations rather than doing them as 2. So what you'll see going forward is that I will set this up as 2 inches cubed times 2.54 centimeters cubed over 1 inch cubed times 19.3 grams per centimeter cubed. And again, anything that's above the line we multiply, anything that's below the line we divide. And of course, this line right here is just a multiplication. Okay. Again, this is how I set things up. I don't care if you set them up this way or not. It's just how I do things. So I want to make sure that that's clear to everybody when I'm doing it. So questions about how I got to my answer? Cool. Awesome. So that's in my opinion, that's a dimensional analysis question. That's something that we talked about last time. And if you have any questions about that, please let me know. All right. So the atomic theory of matter. In order for us to talk about chemistry, everything that we deal with in chemistry has to do with the structure of the atoms that we're looking at. Elements are composed of extremely small particles called atoms. Probably have heard this before. All atoms of a given element are identical. They have the same mass, the same size, and the same chemical properties. Atoms of one element are different than another element. Okay, that's how we tell the elements apart. Compounds are composed of atoms of more than one element. Okay, so compounds are things like H2O that contain both hydrogen and oxygen. If we have two atoms that are together that are the same, like an N2, we typically refer to that as a molecule. Okay, molecules can be compounds. Compounds cannot be molecules. So slightly different definitions for those two. Chemical reactions rearrange the atoms, but it does not create or destroy them. So we have to have the same number of atoms on the reactant side as we do on the product side, which we'll get to eventually. Okay, a couple of lectures later. And then we have this thing called an AMU. You'll hear me refer to this. That's an atomic mass unit. Okay, it's just a unit of measure. Now, if we want to talk about the structure of our atom, we have several subatomic particles that we talk about here. Now, are there other subatomic particles? Yes. Do we talk about them? No, that's a physics thing. Okay, these are the ones we're going to be concerned about. So we have electrons. They were discovered by a guy named Thomson. They're very, very small, negatively charged particles that are distributed throughout our atom. What we see is that they have general patterns that they exist in. They tend to be spherical or dumbbell shaped. It depends on what type of orbital we're talking about, but they exist around that center core. Okay, the area that they take is defined as the atomic radius, so we'll talk about that eventually, but that is where they exist. So they're on the exterior portion of this. Now, in the nucleus here, we have our protons, which are positively charged guys. So these plus right here, those were discovered by Rutherford. Do you need to know the names of the guys who discovered them? No, you don't, but I'm just telling you. All right. So we have our protons, those are the positive charges, and then we have our neutrons, which have no charge. They have mass, but no charge. Okay. Now, protons and neutrons are both much bigger than the electrons. Okay. They have approximately 1 atomic mass unit of mass for each one. Now, they're slightly different, but that's okay. They are located centrally in the atom and contains approximately half the mass of that atom for the protons, approximately. It's not 100%. The neutrons have no charge. They exist in the center of this as well. Okay, that's the other part of the mass comes from that, and they have no charge. Now, should you be able to draw me a structure like this? Yes, you should. Okay, you should know where the electrons exist comparative to the protons and the neutrons. You need to know that there's a nucleus and then there's the electrons around that, and you should be able to label it just like this kind of structure. You may see one of these on the test. Okay, questions about that? Cool, awesome. Now, just another way to talk about those three things that we need to be dealing with. Protons are positive charge. The mass is 1.0073 atomic mass units. Neutrons are neutral, no charge, 1.0087 AMUs. An electron, listed as an E minus, is a negative charge, and it's 5.486 times 10 to the minus fourth AMUs. Okay, so it's extremely small. So we usually don't talk about its contribution to the mass of that particular atom. Okay. Ta-da. We'll get to what those atomic orbitals look like later. Now, comparison. We talked about those. We talked about the symbols, so positive N and E minus, okay, and again, the mass. Now, this is just another way to look at this. I want to make sure that we've covered this in a number of different ways. Now, the number of protons is equal to the atomic number, the number on the periodic table. So this is the atomic number on this particular periodic table thing. So this is a 7. So that's the atomic number 7. I have 7 protons. That's a nitrogen. Okay. The atomic number determines which element we're looking at. The number of electrons should be equal to the number of protons as long as it's a neutral atom. Okay. Those two have to be the same if it's a neutral atom, if you have no charge. Number of protons equals the number of electrons. And the number of neutrons determines which isotope we're dealing with. We'll talk about that in just a little more detail in just a second. Now, this particular periodic table, the one that you're looking at right here, also has an electron configuration, which we'll talk about next time. The name of this particular thing, which is nitrogen. The physical state for this, which happens to be a gas, and has the atomic symbol and the atomic mass. Okay? 14 protons, or 7 protons, 7 neutrons in this gives me an atomic mass of 14.007. Okay. Not all periodic tables will have all of this information. The one that you get on the test has the atomic number, the atomic symbol, and the atomic name. So you should be able to get between the symbol and the name. It's not that easy to read, so make sure that you're aware of that. It's not very big, but all of that is there. I do not expect that you know the names or the symbols without the other one. Okay, so there's that. Questions about that part? Cool.
I do have one quick question. It's sort of unrelated. Just seeing nitrogen on that and thinking about the air we breathe, knowing that there's a lot of nitrogen in it as well as other elements. Is the air we breathe a compound then?
Well, it's a mixture of, no, it's actually a mixture of usually molecules. So, but some of them are just elemental. So helium is by itself, N2 is a molecule, but it's a mixture of those things. Yeah.
Okay, thank you.
Yes. So an atomic mass unit is a mass exactly equal to 1/12 the mass of a carbon-12 atom. Oh, yay, that's exciting. Now, you'll see this symbol 12,6C is one molecule of the isotope of carbon that contains 6 electrons, 6 protons, and 6 neutrons. So its mass, which is listed right here, is the sum of that 6 protons and the 6 neutrons. Okay, so for each isotope, we can tell exactly how many of each type of material we have. So since I know that this is number 6, that's the number of protons. That determines what that symbol is. And of course, then we get to this mass number. Our mass number is equal to the number of protons plus the number of neutrons. Okay, so I can determine from that mass number that since I have 6 protons, then the number of neutrons has to be 6, because it's 12 minus the 6 equals 6. Okay, that's our standard unit for talking about atomic masses. Now, we usually don't refer to them as atomic mass units. Most of the time when we talk about these things, we talk about them in terms of grams or grams per mole. Okay, and that has everything to do with how many of them that there are. We'll talk about that in just a little bit. Getting ahead of myself, I apologize. So that's an AMU in its definition. Now, I mentioned that was an isotope. An isotope, there are things, more than one form of the same element that contain equal numbers of protons, which is why they're the same element, but different numbers of neutrons. And I mentioned that there's a mass number and an atomic number, and then the atomic symbol. So the atomic number determines the atomic symbol. The mass number is the sum of the protons and the neutrons. Okay. So if we're looking at an 11,6C, since it's a carbon and it has 6 protons, all of these have 6 protons because they're all carbon. The number of electrons for that is therefore going to be 6, because we have 6 protons, so we need 6 electrons because none of these have a charge. But the number of neutrons is going to be that 11 minus 6, which is 5. For 12,6C, I'm going to have 6 neutrons. 13,6C is going to have 7 neutrons. And 14,6C is going to have 8 neutrons. Okay? So these are all neutral ions. We'll talk about charged particles in a bit. So since they're neutral, number of protons equals the number of electrons. Cool with that? Now, can I determine the atomic mass of an isotope? Absolutely, I can. And that's what this mass number is. So this symbol is equal to the isotopic mass, which is from the 6 protons plus the 5 neutrons. That gives me the 11 that I see right here. Okay, so if you're asked about a single isotope, you can tell me exactly what that mass is. Right? That is something that you will get asked on the test. Okay, so you may be given the mass number and asked how many neutrons it has. You may be given the number of protons and the number of neutrons and asked what its atomic mass is. Those are things that you should be able to do. All right. The isotopic mass given in the far right column is the number on the top of the symbol of the element. So remember, this isotopic mass is the number that appears up here. Okay. Questions about any of that so far? Now, everybody at this point usually looks at me and says, but in atomic mass, the periodic table, none of those are even nice, neat, even numbers. No, they're not. And that's because we have multiple isotopes of each type of element that we're looking at. The number that you see on a periodic table is actually a weighted distribution of those isotopes. I'm not going to ask you to be able to calculate that, although that is something that you could do. But understand that that's just because there's more than one isotope that will exist for any given element. Okay? So you won't see a nice even number on a periodic table. But for a given isotope, I can say that that atomic mass will be a whole number. Okay? So the atomic masses given on the periodic table are given in grams, non-atomic mass units. The mass of one particle is listed in atomic mass units. So if I'm talking about one particle of that thing, then we talk about that in terms of AMU. If we talk about an entire mole of that thing, then that mass is in grams. Okay? So how do I determine an atomic mass again? We've roundabout talked about this before. So I'm going to ignore the electrons. They're very small, so we ignore them. We find the atomic number of the element. That is the number of protons and determines its chemical identity. The proton counts for one mass unit. Determine the number of neutrons. Usually you'll be told this. Each neutron is one mass unit, and make the sum of those two. All right. Now, if we were going to do the mass on the periodic table, we'd multiply that by the proportion that are that particular isotope, and so that's how we get the numbers that appear on the periodic table. Okay? So I talked about an atom. Go, atoms. Protons, neutrons, electrons. Number of protons is equal to the number of electrons. Number of neutrons is equal to or higher than the number of protons. Okay? So atoms are the smallest unit of a discernible material we cannot break down without chemical changes. So oxygen gas always exists as O2. It's a diatomic gas in its natural form. Carbon, nitrogen. Okay, so those are atoms. We can talk about ions, however. When an atom loses or gains electrons, that atom then has a charge because the number of protons and electrons are no longer equal. So if I want to talk about some different ions that we see a Cl-. Now, since electrons are negative, this means that I have an additional electron added to this Cl. Okay, so one additional electron here. Oxygen 2- has had two additional electrons added to it. And an Fe3+ has lost 3 electrons, and that's why it's now a +3 charge. Okay, so that's the difference there. So let's determine the number of electrons for some things. We want to consider the items listed below. Tell me the following for each species: number of protons and the number of electrons. And actually, I'm sorry, I meant to pull this up earlier. Give me 2 seconds. I had it saved. Cooperate. So I need to look at a periodic table to be able to do most of this. So if I want to determine protons and the number of electrons for a Cl-, the first thing I need to do is find Cl. Now Cl is right here. He's a halogen. He's in the second row. His atomic number, given right here, is 17. Okay, so that means he should have, in its natural state, 17 protons, 17 electrons, and 17 neutrons. Well, it's not actually 17, and I actually didn't ask you about that. But since he's a negative charge, we've added one additional electron to that. So that means that I have 17 protons and 18 electrons. Okay. If we want to talk about H+, we need to find H. He's right here. He's hydrogen. He is atomic number 1. So if he's an H, he has 1 proton. He's a plus. He should normally have 1 electron, but we've lost 1. So he has no electrons. Cool. If we want to talk about phosphorus, he's over here, number 15. So he has 15 protons. And he is a neutral charge, so he also has 15 electrons. When we talk about oxygen, oxygen is up here. He's number 8. So 8 protons. He's a 2-, so he's added 2 electrons. That means he's got 10 E-. Okay. If I want to talk about Ca2+, he is right over here. His atomic number is 20. So 20 protons because of his atomic number. He's lost 2 electrons. That's why he's a 2+. And so that means he has 18 electrons. We want to talk about Mg. Oh, look, he's right there. So Mg is number 12. So he has 12 protons. And he has no charge, so he's 12 electrons. Fe3+, gotta find my Fe. Fe is right here, and I think he's 26 because I can't read that. Yes, 26. So 26 protons. He's a 3 plus, so he's lost 3 electrons. That means he has 23 electrons. N 3 minus, N is right here. He's number 7. We talked about him previously. So he has 7 protons. He's added 3 electrons to that to give him that 3 minus charge. So he ends up with 10 E minus. And carbon, which we talked about a couple of slides ago, is right here. He is number 6. So he has 6 protons. And since he's neutral, he has 6 electrons. Okay. So that's how I would determine all of that. Are you going to be asked to do that? Yes, probably. So that is something that you would probably need to be able to do. And again, all I did was find where is this thing on the periodic table? What's the atomic number? And then how many electrons have I gained or lost because of the charge that I have? Okay?
Will it always be a subtraction or addition of electrons?
For ions, yes. So unless we're talking about a nuclear reaction, which we'll get to eventually, that will be changes in neutrons and protons. But everything else is just changes in electrons. Correct.
All right, thank you.
Sure. Anything else? Okay. Now, molecules of molecular compounds. What are molecular substances? They're made from nonmetals bound to nonmetals. Okay, this is the definition that we use for molecules. Nonmetals and nonmetals. They can either be the same element as in O2 or different as in CO. We use the atomic symbols and subscripts to convey the proportion of the compound. So if I'm looking at O2, that means I have 2 oxygens in it. CO, I have 1 carbon, 1 oxygen. Okay. Molecular formulas are those that represent exactly how many of each atom are in the formula. For instance, H2O2 shows 2 hydrogens, 2 oxygens. Empirical formulas are the smallest whole number ratio of the atoms in that formula. So HO is the empirical formula of H2O2. So it's just the ratio of the HCO. Okay, and there's 1 hydrogen for each oxygen, so its empirical formula is HO. Okay, awesome. Now, hold on to the fact that they're nonmetals bound to nonmetals, because we're going to talk about that when we talk about the periodic table. But that is how we deal with molecules and molecular compounds. Questions about definition there? Cool. Yahoo. Really? Is that really all I had to talk about? Where the heck? Hold on just a second. I apologize. Sometimes I think that technology is wonderful. Sometimes I want to shoot it. Isn't it fun to watch your teacher flounder? Isn't that great? I think it's fun.
While you're trying to find what you're trying to
Yes.
find,
Yes.
is a webcam necessary for any of the tests other than the final, or am I going to need to acquire one?
For the hour exams, yes. For the quizzes, no. So the hour exams require the respondus monitor. The other ones do not.
All right. We have our first one this Saturday, I believe.
The first test is the 29th.
Oh. Oh wow. That's a bit off. All right. Yeah, I can get a webcam by then.
Yeah. Hopefully that won't be a problem. And actually, I am done talking about stuff for today. So.
Oh wow.
The first couple of lectures are kind of short. Don't worry about it. We have lots of things to do after that. Trying to make life easier by doing it that way. What was I looking for?
Just for a quick clarification, I know you've already
Yes.
said this once, but on the lecture quizzes, like for lecture, there's a lecture two quiz that I see in my D2L. Those are really meant to be taken before that class, so I should have taken the lecture two quiz before class today.
That is the design, yes, but today it was
Okay.
not required, so not a big deal.
Okay. Okay.
I again didn't expect people to remember that today, so not a problem at all. But yes, that is the idea is to. I mean, it's twofold. One, so that I can get an idea of what you guys did and didn't understand from the lecture before. That's really what that's for. And then so you guys can look at the topics that we're going to be talking about for the day. That's really what it's for.
Okay.
And those are generally what, 5 minutes before class is when
They open at midnight, so you have plenty of time
Oh,
before
okay.
class. Yeah.
All right, that works. That works.
I have a question.
Yes.
Where can we find the recorded lectures after the lecture?
I'm going to be posting them on D2L. I'll put them in the content section. They'll go with the materials for that particular lecture. I haven't, for whatever reason, while I recorded the first lecture, I haven't been able to get my hands on it. I'm not really sure why, but the university has made it so that I can't get it without requesting it. So I've had to request that from them, but I've changed the way that I'm recording it so that this one will be available just after this. So
Okay, thank you.
yes, absolutely. Yeah. The 29th is your first exam. It is meant to be taken during this class time. So I will be available via WebEx if you need to talk to me before or after. But yeah, that's when your first exam is. And we will cover lectures 1 through 6. We'll also have done lecture 7 to give you a little more time just to process the stuff from lecture 6 before you take the exam. Anything else? Now the lab stuff has also been made available to you. Two of the virtual labs haven't opened yet, but I can make them available if you want them. There is a lab lecture that I have recorded that goes with each of those. So the mass and volume experiment information is here. You'll see that there's a lab lecture that goes with that. It is absolutely not necessary for you to watch that. That is just some information about me prattling on about what you're doing and why you're doing it. You don't need to watch them. You can just do the virtual experiments. Not a big deal. This particular time, there are 4 of them that you were supposed to be doing. They're not very long, so it's just how you would use the laboratory equipment. So pipettes, pipettes, balances. That's the word I was looking for. Things like that in the laboratory. Now, it's important that you understand how those things get used. If you go into a physical lab at some point, you'll need to spend a little time actually doing it because it's a little harder than it looks on the virtual labs, but there is that. And of course, if any of you want to come over and take a look at that stuff, I can arrange that, but that is absolutely not necessary. So I would use the rest of today's time to go and do your virtual labs. But of course, it is your decision. You're adults. You can do whatever you want. So if anybody has any additional questions, I am going to be here. I will be happy to talk to you about anything. But for the rest of you, if you're good, then I will see you later.
Just a
Yes.
quick clarification.
Yes.
Just to make sure I'm understanding it properly, because I went back through. I know I missed the first day of class, but I went back through the first lecture on significant figures. For the example we covered at the beginning of class, the 632.5406704904 grams. When you're getting a significant figure, you're taking the decimal point either forward or backwards until you're one before or after the initial number. So for the significant figure you gave here, It's 6.3 to 0.54. So you would take the point go before 2, before 3, before 6, and that's how you got the 6 times 10 to the third.
Correct.
Awesome.
That is correct. Yes.
All right. Just want to make sure I was getting that right because I know I missed that lecture.
Well, that part we actually didn't do during class. That was an additional one just in case people had questions about sig figs. So.
No, yeah. But all right, that works for me.
Sure. Anything else, guys? Okay, like I said, you were free to go and do lab stuff. And again, I will hang out here until the end of class, i.e. 10 a.m., just in case anybody has any questions that come up. So I will be available to you guys for that.
I guess if it's question time, I have a few more if you don't mind.
No, go ahead.
So for just in terms of like scheduling, the I think it was I've printed them all out. I think it's the lab schedule you gave. There was a schedule. I want to try and find it real quick.
First documents, schedule.
Yeah, lecture schedule. Is that also kind of the suggested schedule for when you should finish things as well, just to keep on top of everything?
Well, okay, so we covered atoms and atomic structure today. There is an Alex assignment that goes with that. My recommendation only, is that it be done 2 days from now, i.e. before the next lecture, but that is not required. It is not actually due until the 27th, which is 2 days before the next exam. So that's the actual due date for that. But just my philosophy on that is don't let them pile up, because there may be things that you're not understanding and you won't know that until you do the practice.
All right, gotcha. And then if we do have any questions, the office hours listed on the home page. That would be a good time to contact you.
Yeah, anytime then or here.
Can that be done through WebEx, or is that like I need to email you and?
No, I have a WebEx that's open during office hours. It's my personal one, and you can just drop in. Not a big deal.
All right, awesome. Thank you so much. You have a
You're
lovely
welcome.
day.
Thanks, you too.
Hey, I emailed you and then I said,
Yes.
I'll talk to you after class. Yeah. Like I was doing the lab stuff, but with
Okay.
the lecture homework as well. Um, and then I was stuck on number 9, I believe. Let me just go ahead and check. Um, yeah, I was stuck on 9, 11, 12, and 13. And then I was like, am I like missing something? Am I supposed to look at another lecture or anything like that? Because I wasn't sure if we covered that or not.
And this is the matter.
Yeah,
And
matter unit measure.
and 9. Subtracting and dividing measurements. This one?
Yeah, it's that one.
Okay. So on this one, I'm looking at the units that are listed here, and you see that it says grams times milliliters to the -1. So what they're looking for is what is the correct and let me what they're looking for is what is the correct mass that goes with that, and then what is the correct volume that goes with that. Let me open this again. Closed it. That's silly. Okay. So the graduated cylinder says the empty weight is 9.20 grams. With the sodium thiosulfate added, the cylinder weighed 66.58 grams, minus the 9.200 grams that we started with, because that was the empty weight. So weight by difference would then be the 66.58 minus the 9.20, and that gives me 57.38. And I leave it as 38 because I only want 2 decimal places on that. We need to line up the decimal places. So that's the mass.
Okay.
When we talk about the volume, it says, examine the total volume of the solution from the markings on the graduated cylinder. Total volume of the solution was 129.21 milliliters. So if I want grams per milliliter, we'd be looking at 57.38 grams, 129.21 milliliters. 57.38 divided by 129.21. And that gives me 0.444. And I have 4 sig figs there. I have 5 there. So when I round to 4 sig figs, I get that number. And that should be what I need to put in there. And the only thing that we're looking at there is what are the units that they gave me. I just want to make my units the same. So it's not. Go ahead.
So for the units, it's like grams times milliliters. So would that be just like an opposite to do for like you divided by like grams milliliters?
This is actually grams per milliliter because it's milliliters to the -1.
Oh.
That's why I got the grams over the milliliters.
Okay, so it's an inverse of that.
Yes, for the milliliters. Yes.
Right. Okay.
Yes. And that's how you do that.
Yeah, that makes more sense. Now it's just like
yeah, so much fun. I know. Where did the rest of them go? You asked about 11.
I believe it's the same sort, but you just have to convert it into milliliters.
Yeah, so on this one, 45 grams, and then they tell you that the density is 0.790 grams per centimeter cubed. So if I want to get an answer, and one other thing that you need to know is a unit conversion. 1 centimeter cubed is equal to 1 milliliter. And I think, I'm pretty sure that is not there. Where's my data?
So are we gonna like on the test? So are we gonna get like a conversion sheet?
So the exam handouts have conversions in them. Page 2 is a list of conversion factors. So there are some that will be there, and there's a unit conversion thing for SI units here. So
okay. You said page 2, right?
It's page 2 of the handouts, yes. And if it's not there, it should be given to you.
Okay. Oh yeah, I do see it. Okay. So it's just like 1 meter, one like distance, weight, temperature, and volume. Okay. That makes more sense.
Yeah, and
That's why I was more confused. I was like, I don't see like the unit conversion because I took like engineering 269 and they had conversions and stuff. I'm like, I know how to do this, but I don't see a conversion sheet, so I was like confused a little.
And I would expect that conversion to be somewhere in here. Now, where it is, I'm not sure exactly, but.
So you said 1 centimeter cubed is 1 milliliter?
Correct. That is correct. And again, I'm not sure which of these tables it's in.
Right.
An actual SI.
If we can't find it on Alex, we are allowed to use because I printed them off. We are allowed to use them on the.
Oh, yeah.
Okay.
Absolutely, you can. The only thing I would worry about is that sometimes the number of sig figs or the actual value varies slightly. So if you use something that's not in Alex, sometimes it freaks out about that.
Okay, I remember you said that yesterday.
Yeah, it can be very painful that way.
But if we can't find it, like right now, like what if we aren't able to find that conversion, like through the Alex conversion? Then will we just email you and say, hey?
You can either email me or you can Google it and use whatever you find. And when and if it freaks out about it, then email me and tell me, and I can fix it.
Okay.
I can give you the points back for that because yeah, it happens, which sucks, but it does. Oh, and sadly, they may not have put it in here because sometimes we forget what you don't know. I try to be very cognizant of that, but sometimes we use something so often that we just forget that people don't actually know all of it. So it may not be in here. And like I said, I don't see it anywhere. So that's probably an assumption that they made that you would know that. Just a bad assumption, but that's okay. So yeah, once you have the unit conversion, you should be fine to do that.
Okay.
And if you want me to show you the
I'm
rest,
so
I can.
confused. I'm like, I know how to do unit conversion by heart. I just need the sheet.
Yeah. So
Looking
you
for
should
a
be able to
lot.
find anything that you're looking for within this data section in
Okay.
Alex. And again, if
Okay.
you don't find it, tell me. I'll find it for you.
Okay. Okay. Appreciate that.
Yes, no problem. Because that is not something that I expect you to know. It is
And
my
then
opinion that Google exists for a reason.
right. I try to do that, but myself is just I'm thinking like, what if this is not on her data sheet and I'm just looking at something like a better like or you know, I feel
Right.
like it's cheating some sort. Like, it's just like
Nope. No,
so
there is
yeah.
not. And if and unfortunately it has happened. Sometimes I forget to give you a particular conversion factor, and if you don't have it staying on the test, I don't have the right conversion factor, but here's what I would do with it.
Okay.
Is perfectly fine.
Okay. All right. So the tests are online, right? Or do I
Correct.
come in person with okay.
Yeah, you don't have to come in. If you choose to come in, I can make that happen, but you are not required to.
Okay. Because I did see it's in hybrid classes. I was just like making sure. Because usually with the hybrid class, you would have to come in for the test.
Nope,
So,
we will
okay.
do those electronically unless you choose to come to the testing center.
Okay. Makes sense.
Yep.
I think that would be all for me.
Awesome.
I
Any
really appreciate the
yeah.
help for the
Oh,
questions.
you're very welcome, and I'm sorry that you had to ask.
Oh no, it's all right. I should have explored my
No, it's
something
all
that I need to use or take a look at.
it's
I'm
all
new to
it's
Alex,
yeah.
so
Well,
yeah.
how can I put this nicely? I'm not a fan.
Oh, okay.
The labs seem
Yes.
similar to the ones we did for micro, but I haven't done the quizzes yet. And I did go through the content, but I it has that little progress thing at the bottom.
Okay. The progress thing is
Yeah.
not important. So what you're gonna find when you come into Alex, and let me see, I need to get to here's my student view. So when you're in Alex, it will have a progress bar. The progress bar is not important to you because what they're measuring that against is what they think everyone should cover for this course. And we don't necessarily cover everything that they expect we would cover. So
Okay, I was
your
following that.
Yeah, your assignments are the only things that you're required to do. At the end of the course, what we will do is go through and look at your pie progress. Your pie progress is measured as so the Alex progress is measured as how many of the assignments did you actually complete. So if you did them all, then you get 100% for that. The Alex total is a weighted measure. So if you got 100% on everything, you get 100%. If you only got 89% on something, it'll be slightly lower than 100%.
Okay.
But that's calculated manually at the end of the course and will be put into D2L after it's manually calculated.
Okay. And then the okay, so you said quizzes before lecture.
Yes.
Um,
And those are in D2L under quizzes. You'll see there's a lecture 2 quiz. That one's available to you. The other ones are future quizzes, so they're not open yet.
okay. Okay. Okay, because I was like, quizzes, are they in Alex? Like, if you
No,
did expect us to do it, I was not one of the ones that was
it is all right. I kind of figured that people would not remember on the first one, and that's perfectly okay. Not a big deal.
Okay, I will. So at this point, because I want to be able to keep up, these are literally like my last 2 classes before I graduate. And I would hate to like fail like right before graduation. So I want to be able to
Understood.
keep up because micro was just so much work. It was a lot. That was a dense course. So I don't want to fall
Yes.
behind. So at this point right now, I am like while you were explaining everything to Yash, I
Mhm.
was working on the first virtual lab.
Yep.
So tonight I would need to do those 2 virtual labs, the tutorial and then number 1, and then the lecture quiz, and then go through and start filling out the exam handout for the first part that we've learned, like the first 2 lectures,
Well, the exam handouts are already filled out, so that's actually just a bunch of information.
or the review. I think there's a review in there, correct?
Oh, there's a scavenger hunt? Is that what you're talking about?
Yes. When should we start working on that?
Yeah, that's
'Cause
due
I
by the
see there's
16th. And so this is the scavenger hunt is just to help to force you to look through some of the course documents to see what policies are. That's what it's for. And again, it's not going to be. I mean, it looks like it's graded, but that's only because I wanted to be able to give feedback if you didn't get the right answer. At the end of it,
okay.
you will get 100%. Not a big deal.
Okay. And then I see exam 1 practice. We should go ahead and start like working on that as we go through lectures.
You can absolutely. It's not
Okay.
it's not really demarcated as to what goes with which section. So
Mm-hmm.
it may not be clear to you
Oh,
which
okay.
goes with what, but that's okay. If you don't know how to do something, then you can ask me about it. I'll be perfectly happy to tell you if we haven't gotten to it yet, or you can wait
Okay.
and see if it comes up later.
Okay. All right. That sounds good. Thank you so much.
Sure, no problem.
If I have any more questions, you'll still be in here, right?
That is correct. I will be here until 10. And if you have any other questions at any time, let me know.
Okay. Thank you.
You're welcome. Have a good day.
Thank you. You too.
Thanks. Hi, Tyler. What's up?